So here's a VESC Duet connected to a Flipski 63-100 motor with 190 kV. And I also made some adapter cables here because the motor has 4mm bullets and the Duet comes with 5.5. So if you buy one, you have to make sure that you get the bullets or that you have a motor that has one. Or you can also resolder the cables if you prefer something else there. So I'm connected over USB and it will show up in VESC tool here if the connection worked well. And now when I connect, you will see on the CAN devices here that I'm connected to the Express on it. And then I have the two Duet devices that are Moto 1 and Moto 2. And when you want to configure the motors, you have to pick the motor on the CAN list here. And you can do the same thing in the mobile version on the CAN list. And I will try to configure this motor for running HFI. And then I will also, or before that, I will set up logging on it. So I will collect a log of the test. So I will start by going to Moto 1 and then I will go to the package store, update archive to make sure that they're all on the latest. Select the log UI package and install it. And now when you go back to Welcome and Widgets, you can see the log UI on the right side. And you can see if I switch to another CAN device, it's disappeared. So it's installed on this one in particular. You can also install it on the ESP, but then you will get a bit fewer values because if you install it on the motor controller itself, there's more data available. So for this log, I will disable GNSS because I don't have a module plugged in. And if I have it enabled and no module plugged in, the log will not start because it will not get any valid position. And I will set the logger CAN ID to 2 because that's the CAN ID of the ESP. And I will save the config so that next time I connect, it will have this config again. And now I will start the log. Now it should have a file on the internal memory card chip on this one. They all come with one, and you can read out the files from it either over USB or over Bluetooth or Wi-Fi. Now that I'm on Moto 1, I will go to the current limits. Yeah, I set it to 150 here before. I will start with 120 amps phase current. And on this one we have, if you run hardware status here, you can see the current measurement range. And this one can measure up to 330 amps per channel. So that is a lot of range, but the measurements are very clean because we got the shunt amplifier routing and everything really nice on this one. So even with this range, you can do HFI on even small motors very well. So now we have that set up, and I will do a detection. I'll actually read out. It's already there, but I will show the steps again because I did this before. Resistance inductance, flux linkage. Apply and write. And from my previous test, it was set to HFI, but now it's sensorless. Or I will start trying with sensorless to keyboard control. And try to speed it up. Spins really fast there. And now we do 45-degree HFI. Right, and I will do 10% duty cycle control. And you can see behind here what the current is right now. And I will try to stop it with my hand. And now I see we are pushing 120 amps at standstill. Super smooth on this one. Let's go up to 150 amps. And don't try the same on the bench, because even at 120 amps now, it felt like my 3D print holder was about to break here. And this, if it works, will be even more torque. Let's try that. 150 amps HFI. Can barely hold it and it's hurting in the hand now. So that is pretty impressive. So you can, if you have this on something like a mountain board and you have motors, you can get perfect torque from standstill, even on very high currents, and you don't have to have any sensor in it. It easily fails if you get a bit of water inside the motor, which is hard to avoid when you ride in dirt and so on. Now we can see if we got the log. So we'll go back to Welcome Wizards, stop log. Then I will go to the Express, because that's where they are, the ESP. And go to log analysis. And here we have, in source, we have connected devices. And here we can do refresh. And then we have the logcam directory. And here we have one file. And what I'm plotting now is the input voltage. And here I will plot the current. So you can see here, during detection, we had 40 amps current. Here in my first test, we had 120 amps current with HFI, and up here we had 150 amps. I will select Y1 on this value, then I plot it in this Y-axis, and then I can do MOSFET temperature here. For example, in Y2, then we have it here, and we can see them overlap like this. Otherwise, if you put both of them in the same axis, then it's hard to see the scale. So you have an option to do that now as well in the latest stable VESC tool. And you can see here, as we are pushing current, the MOSFET temperature goes up. And here at 150 amps, it goes up a bit more, but we never exceeded 45 degrees here in this test. So that worked really well. So HFI setup on one motor, installed the log package, did the log, and one more thing to note about the logs is that you can check start logging at boot, and then every time you start up the device, it will create a new file for you. And if you have a GPS receiver plugged into the port on the side here, then it will also log a GPS trace if you have this box selected. And when you look at the logs in the log browser, then it will also have a date here, so you can see exactly which date and time each log was made. So that concludes my demo.